Okay, you're on 106.9 Gove FM. This is the Science Hour, and I'm very lucky to have on the phone here with me today Jeffrey Bennett. Good morning, Jeffrey, or good afternoon to you.
Good morning, Ian. Appreciate your being up so early.
Yeah, that's right. Yeah, well, it's a very balmy 27 degrees here. How is it over your way?
The same, but Fahrenheit.
Now, for our listeners' benefit, Jeffrey Bennett is a very prolific science author from the United States over in Denver, and Jeffrey's written a number of books, starting out with a series of children's books, which are very widespread across schools in the States. These books basically, well, maybe you can tell us a little bit more, Jeff, what the aim of these books is.
Well, the aim of the books is to teach kids science and get them inspired about space and space exploration. So I have 3 books. They're called Max Goes to the Moon, Max Goes to Mars, and Max Goes to Jupiter. And Max is my dog, so he goes on these space missions. And the books have a picture book format so that the story is fairly simple. The pictures carry a lot of the information. But then on the sides of the pages, we have what we call the big kid boxes that explain the science in much more detail, so that there's really quite rich scientific content in them.
That's great. And I don't think I've met a kid yet who doesn't like space and any stories about space. That's a great way to get the science happening.
Thank you.
Yeah. Now, Jeff's also got a number of other books, more popular books, Beyond UFOs, probably the best known of those, taking a look at the universe, I guess, and our place in it. And also a number of leading college textbooks on astronomy, mathematics, astrobiology, among other things. That's pretty much it, I guess, Jeff?
That's what I do with my time, yep.
I don't know how you find time for much else. Now, we're going to have a chat with Jeff about some of these topics, and certainly they're topics that we've explored here on the Science Show a number of times. But look, just starting out, Jeff, like I said, we've talked often about the possibility of life in our solar system here on the Science Show, and as my listeners would know, there have been a number of missions that have gone out to other planets. Where do you think we're most likely to find primitive life in our solar system, and why is that?
Well, I'm actually, I probably fall into the category of what you might call a life optimist. I suspect that we are eventually going to find life on several of the worlds in our solar system, including those you mentioned. And I think first will be Mars, and that's a matter of the fact that Mars is the easiest world on which to look for life, at least given our current technology. Now, we can't actually really do that yet. We've sent the Phoenix lander, we've sent the rovers, but they're not really equipped to actually detect life the way we think it might exist on Mars, which would be deep under the surface, microscopic. We're going to have to build a stronger foundation in terms of knowing where to look with further robotic missions before we can really search for life. But I think once we get that search going, we'll find it there.
Yeah. Now, look, you've also been quoted as saying that robotic life, robotic life, now that would be interesting, wouldn't it? That would really give us a surprise. But finding life on the planets in our solar system, that perhaps the robotic missions are not the best way. A manned mission might have benefits. What's your thinking on that?
Well, I think that in terms of actually looking for life, certainly having people go to a planet is going to make it easier because you can change your experiments, do things on the fly. But actually, robotic missions could probably do it too. We could scoop up samples from deep underground at various locations on Mars and send them back to Earth for study in laboratories here. The main reason that I personally favor the manned missions is because of not so much for scientific reasons, but for what you might call educational and inspirational reasons. I think that the most important aspect of studying the universe is for the way that it teaches us about ourselves as a species and about what we need to do to take better care of our planet and so on. And I think that we want kids to grow up and we want them to be inspired to want to think about the universe, to want to think about exploring the universe for themselves. And when you look at exploration of the planets, that's where we could in principle go, sending people. And it's always going to be more inspirational for kids to think about going there themselves rather than just watching a robot go there.
I guess we don't hear great things said and written about the first robot to go to the moon.
Correct. It's been rather forgotten, hasn't it?
Yeah, I think so. I'd be hard pressed to name the first one myself. So, what do you think it is that exploration of the planets of our solar system can tell us about our own planet, that very important blue-green planet that we live on, and probably need to learn how to take a bit better care of?
Well, it can tell us a lot, and in particular, when we look at some of the nearby planets, Venus and Mars, we've learned a lot about how climate works by studying those planets, because they're both, in essence, failed experiments in climate control. They both may have started out with climates that were much more hospitable to life than they are now, but then things went wrong. Mars essentially freezing and Venus spiraling into its runaway greenhouse effect. And so knowing that helps us understand why is it that Earth has not suffered a similar fate, and what do we need to do to ensure that we don't inadvertently cause Earth to suffer a fate similar to what those planets have gone through. When you look beyond that out to the more distant reaches of the solar system, you start to find all kinds of interesting things about how atmospheres work in general. Storms on Jupiter, Saturn, Uranus, and Neptune may help us understand weather patterns and storms here on Earth. And then, of course, the search for life could tell us a great deal if we found life on another world about what life really is, how it's defined, and we could do comparative biology, which would tell us much more about life on Earth.
Yeah, that certainly would be interesting, and we have talked before about on this show about the places on Earth where life are found, which I think a number of people would find quite surprising. Not just on the surface in the sun or even in the oceans, but deep below the Earth's surface.
That's right, and that's one of the things that gives us reason for optimism about the possibility of finding life on numerous other worlds, because if you're looking for life that was like us humans, you wouldn't find it anywhere else in our solar system. But when you start looking for some of these, what we call extreme forms of life, extremophiles, that we do find on Earth, there are conditions under which they could survive on other worlds, and so that means there could be that kind of life there already.
Yeah, that's right. And look, do you see the possibility of life being found in our lifetimes or in our children's lifetimes within our solar system? And if so, where would you see that being most likely?
I think, again, I would say Mars is the most likely place, and in terms of when, it's really a matter of budgets and political will. If we sent a human team to Mars, they would probably be able to search around and find it if it's there. But that still seems to be at least a couple of decades away, possibly longer, depending on
we might have to wait for this recession to finish, perhaps.
Yep.
Yeah. Of course, I can't help but think about Europa and the possibilities there, but I guess the logistics of doing something on Europa is quite challenging.
Logistics for Europa are very challenging because the life would presumably be in the ocean, which is under, several kilometers of solid ice. Now, there's at least some possibility that water occasionally wells up from the ocean to the surface. In fact, it probably does that. So it's possible that if you simply landed on the surface of Europa, you could maybe find evidence of life that had finding the remains of dead organisms that came up through the ice at some point. But really, if you really want to look for it, you probably need to find a way to put a robotic submarine down into Europa's ocean. And that means having a heater that melts its way through several kilometers of ice and gets down into the ocean and has some way of transmitting the information it gathers down there back to a spacecraft in orbit and from there back to Earth. So it's a major project to really do that. But certainly could be done within our lifetimes or our children's lifetimes if we have the will to spend the money on it.
That's right. And I guess that kind of thing, we'll have to see if we can do it here first before we even try it on another planet.
That's right. And people have been experimenting with things like that down in Antarctica.
Yeah, for sure. We've certainly seen that before. Well, that's really interesting. We'll have a short break, and Jeff will come back and have a chat about life beyond our solar system.
Great, thank you.
Okay, and you're back on the Science Hour. I've got with me Jeffrey Bennett, author from the USA, a very prolific science and space author. You're back with us, Jeff?
I am, thank you.
Great. Look, looking out beyond our own solar system, listeners to this show would be familiar with the fact that there are other worlds out there, something that I must say not everyone's familiar with. But there are over 300 other planetary systems in our own galaxy within, I believe, a few thousand light years of Earth. So what are the implications of these recent discoveries in the search for life out there in space?
Well, I think these discoveries of planets around other stars are probably one of the most important discoveries of the last century. In some sense, it was expected because we've, for a long time, based on our theory of solar system formation, thought that other planets should exist around stars because the same processes that gave birth to the planets around our sun should have operated around other stars. But in science, we can never just assume something's going to happen. We need the evidence that it really did. And that started to come in 1995 with the first discoveries of planets around other stars. And it really validates this basic idea that the Earth and our solar system are not unique things in the universe, that planetary systems are common. And once you have that knowledge that planetary systems are common, it becomes increasingly difficult to believe that Earth could really be unique, and it makes it seem all the more likely that we're going to find life and maybe other civilizations out there.
Yeah, the interesting thing is when we first started discovering these planets, we didn't exactly discover what we expected in the classical model of our solar system with the rocky inner planets and the distant gas giants, did we?
That's correct, and for a while it was really throwing astronomers, and maybe it still will as we learn more. But I think most astronomers think we're getting a pretty good handle on this, in that the leading model suggests that the planets did form in these other solar systems the way they did here with the rocky inner planets and the gaseous outer planets, but then various dynamics of the way that the planets interact with gas and with each other caused migration that changed the orbits of some of those planets, so that we ended up with some of these very massive planets orbiting very close to their stars. And so the big question is that the common rule, and most solar systems end up changing from their initial appearance so that our solar system would be a rare case? Or have those just been the easy ones to find, and as we find more and more, we'll realize that most solar systems are like ours, with rocky inner planets and gaseous outer planets? And I would say that right now the evidence is starting to look like it's going to go that way. We're finding more and more planets around other stars, and we're finding more and more that begin to look like they may be parts of systems that are like ours.
Yeah, there's some very interesting research there, and I've talked to one of our very prominent planet hunters over here in Australia about this, and it's a pretty exciting science to be in, I think.
It is.
Yeah.
Oh, go ahead.
Yeah, sorry. We've got a little gap, haven't we, between our conversations?
Slightly.
Yep. Now, look, the simple maths of it would make it likely, in fact, that there is life on these other worlds. Yet there is a group of scientists who proclaim that the so-called rare Earth theory, that our Earth is a rare and some might even say a unique thing. A little bit egocentric, perhaps. But what's your thinking on this?
This is a very interesting topic. I actually devote a fair amount of space to the rare Earth ideas in my book Beyond UFOs. And, they raise a lot of interesting arguments, and it's possible that they're correct because we don't have the data to prove that they're not at this point. However, to me, it seems like they are trying to hold on to the last vestiges of thousands of years of belief that somehow the Earth holds a special or central place in the universe. You can go back a couple thousand years, more than a couple thousand years, to Aristotle, who had a great argument about why the Earth had to be unique and there could not possibly be life anywhere else in the universe. That argument, unfortunately, was based on his belief that Earth was the center of things, where gravity made everything fall, and we know that that's not true. Later, people still thought that Earth was the center of the universe, but then we found out that it's a planet going around the sun. We still thought the sun might be in the center of things. We found out that it's just quite far from the center of our Milky Way galaxy. And as recently as the last century, 1920s, it was still not known whether our galaxy was the whole universe. And now we know it's just one of 100 billion galaxies in the universe. So it's possible that at this last stage of looking for life, the rare earthers will turn out to be right, and life is very rare. But I think we're going to find that just as all those other arguments fell by the wayside, it's going to turn out that life is very common in the universe.
Yeah, I think so, and you just have to look at, I guess, human history on the Earth here with each successive civilization thinking that they're the center of civilization, that the rest is where the barbarians are. And it hasn't usually
right.
turned out to be true.
That's right.
Yeah. Now, look, assuming there is this abundance of life in our galaxy, do you think there's intelligent life? And in the face of this possibility, could there in fact be a galactic civilization thriving around us, with the Earth simply being off the charts? And for those who've followed the writings of Douglas Adams, Hitchhiker's Guide to the Galaxy, the Earth is perhaps just considered mostly harmless and of not much interest.
Well, I think he's probably on target with the mostly harmless. I don't know that we'd necessarily not be of much interest, because if they're at all like us, we'd be of scientific interest at least. But yes, I think it's quite possible that there's an abundance of intelligent life. And this is where you start to get some really interesting arguments when you go through the numbers. There are 100 billion stars in our Milky Way galaxy, actually several hundred billion. If you assume that just one in a million stars ends up with a civilization on one of its planets at some point, you get 100,000 civilizations in our galaxy alone. But you wouldn't expect that they've all just come up like us at the current time, because it's been possible for Earth-like planets to form, at least in principle, for the last 10 billion years. And so you would have these 100,000 civilizations spread out through time. I like to pull the number of spread out over the last 5 billion years, because when you do the division, you get this nice answer that you expect on average one civilization to rise up every 50,000 years. And what that means is that if the civilizations don't destroy themselves, if they survive, then the next youngest civilization in the galaxy besides us is 50,000 years ahead of us technologically. And the next one before them is 100,000 years ahead of us technologically, and so on to ones that you would expect to be millions or billion years ahead of us technologically. So yes, if they are out there in the galaxy, they are far, far, far beyond where we are.
Yep. So, and I think it's been quoted so much so for their technology to seem to us like magic.
Correct. Arthur C. Clarke's famous quote, "Any sufficiently advanced technology is indistinguishable from magic."
That's right. Now, you've been quoted as suggesting there are 3 possibilities as to where the aliens are, because people, of course, will say, well, I don't see them. I only hear reports of Area 52 and all that kind of thing, which are not given a lot of credibility, except by those who are proposing it, perhaps. Can you tell us a little bit about where the aliens have gone?
Yes. This question, where is everybody, is sometimes called Fermi's paradox, because Enrico Fermi first posed the question, maybe not first, but he posed it in a discussion with other scientists back around 1950 or so. And it was looking at this point that if you just look at the numbers, even back then, if you just looked at the number of stars and thought about reasonable arguments about the number of planets that are probably out there and so on, it seems like there ought to be civilizations all over the place, and aliens could have been here by now. And yet, other than those reports of claimed visitations, we don't have any actual evidence that aliens are, in fact, here visiting us. We've not made any contact with SETI efforts or anything else. And basically, I say that you can divide the possible answers to this question of why we have not detected other aliens yet into three different categories of answer. The first category is they're just not out there. We're basically alone in the universe. That's what some of the rare Earth people might argue. But as I mentioned before, I find that unlikely. It's certainly possible, but I wouldn't bet on that one. The second possibility is that there are lots of civilizations that have arisen, but for whatever reasons, they're not talking to us or not available for us to make contact with, and that's why we haven't had any contact. Now, that's very interesting when you probe it more deeply. In fact, it's rather scary when you probe it more deeply, because you have to ask why, if there's been lots of civilizations, wouldn't they be talking to us? We would talk to them given the chance. In fact, we've been trying. So one possibility might be that they're somehow different from us. They just don't care about the same things we care about. And that, of course, is possible, but when you think about how evolution has led to our basic instincts and the kinds of things that we as humans do, it would seem like you would have at least some civilizations that would have the same sorts of drives and would want to make contact. Then you come up with the possibility that perhaps the reason they're not contacting us is because they don't survive long enough to do that. If the next civilization arose 50,000 years before us, and if they destroyed themselves after a couple of centuries of technological development, then they're not there for us to hear right now. So that's the second category of possibilities, where they're not making any contact with us, leads you to kind of this scary conclusion that maybe it's very difficult to survive as a civilization once you develop high technology. If you then go to the third possibility, which is we rule out that we're alone in the universe, we rule out that they all destroy themselves, then we're basically left with the idea that there is a galactic civilization out there. And this is where my scientific friends like to kid with me a lot, because I would argue that given everything we know now, that is the most likely scenario, that we are, in fact, surrounded by a galactic civilization.
A little mark on the charts that says, "Do not disturb primitive civilization."
Sure, the prime directive, if you're a Star Trek fan. I don't know if you got that there in Australia.
Yeah. I don't have to work too hard to reveal my true colours there, I tell you. So, yeah, that's interesting. And, of course, there are people looking for these potential civilizations, and I guess the best known amongst them are the people from SETI. What's your thinking on the possibilities of what SETI are doing, and where do you think that might lead us?
Well, I think SETI efforts are very worthwhile. As some of the founders of the project said many decades ago, if you don't search, then your chance of finding them is zero. And the question is whether what they're looking for, these radio signals or perhaps a visible signal, could really be coming at us. And what we're really hoping is that these civilizations, which most likely, if they exist, are far beyond us technologically, are still using primitive technologies that we're capable of receiving for the purposes of letting other civilizations that are coming up know that they're out there. And that's been a popular science fiction scenario. Carl Sagan wrote about that in Contact, which became a movie. So I think that the SETI efforts are well worthwhile, and I hope they make contact.
Yeah, certainly. I hope it's in my lifetime. Okay, look, we might leave it there for a while, go to a bit of a break, and after that we'll come back and talk about where to from now.
Great.
And you're back on 106.9 Gove FM. This is the Science Hour, and I have with me on the line Jeff Bennett from the USA, a very prolific science and children's science author. You back with us there, Jeff?
I am. Thank you.
Fantastic. Now, look, you have been a very prolific writer of children's space science books and numerous school visits, which I don't know how you find the time for with all those schools over there. What's your fondest hope in the work that you're doing there?
Well, I think that probably from what we've already talked about, you gather that I'm very, I think that the study of the universe is very important to understanding our place within it, and that it can have a real effect on how we treat each other as human beings and how we treat our planet. I like to quote H.G. Wells, who once wrote that civilization is evermore a race between education and catastrophe. And I think that's very true. If we don't educate people so that they understand these things about the universe and understand the things we need in order to get along in a very interconnected world, we will end up moving towards catastrophe. And my goal with the children's stuff is to try to start that education process at as young of an age as I can. The school visits are great fun.
I'm very much with you on that one.
Good. Appreciate it.
That's right. Even a little bit of education goes a long way, and certainly there are many, many misconceptions out there in the world, even amongst our seemingly well-educated populations of the so-called first world, let alone across the planet.
That's right. And one of the tremendous things about the interconnectedness of the world today, particularly with the Internet, is the possibility of offering education to people who otherwise were really unable to get it. Now, with projects like the One Laptop Per Child that are trying to put laptops in the hands of poor kids in rural villages everywhere, with that, in principle, they could get access to the latest data coming down from space missions, robotic space probes, the Hubble Space Telescope, and so on, and you could have kids in poor rural villages making scientific discoveries. And in fact, some of that has already happened to some extent.
Yeah. Look, it certainly has. You see it now, across the world. The new space programs starting up, and a huge body of science being done, pretty much in every corner of the world now.
That's right.
Yeah. Now, look, with everything you've done, I can't imagine you stopping anytime soon. What's your next project?
Oh, good question. Most of my time is actually spent working on my college textbooks, so everything else is kind of a hobby for me that I do on the side. But I've got a list of some more children's books that I want to write, and a couple more books for the general public that I would like to do. There's one I've started outlining that will be on math, since I have a textbook on math also, and I think that the current global financial crisis is the fault of everyone who teaches math, including myself, because we haven't done a good enough job of teaching people some basic things. People bought into these mortgages and stuff just listening to what somebody told them, when with a little bit of mathematical understanding, you would have realized that can't be true, and we could have avoided this whole mess. So I think we need to do a better job of teaching math to the public, and I hope I'll be able to do a book that will do some of that. And I also plan to do some... Oh, go ahead.
Sorry, the old story, if it sounds too good to be true, it probably is.
That's right.
Yeah, look, that's great, Jeff. Now, we'll pretty much wrap it up from here, but what's the one thought that you'd like our listeners to take away from our discussion today?
I hope that listeners will really think about these numbers of worlds out there and the possibility that we are not only not alone in the universe, but that in fact the universe is filled with civilizations, or a galactic civilization that is far, far more advanced than us. And what that means is that we are at a real turning point in history, because we've reached the point where we have technology that might, if we continue to develop it, allow us to join that civilization, or if they don't exist yet, be the ones who start it. Or we could use that same technology and end up destroying ourselves if we don't use it properly. And I think it's really important for people to realize that this turning point is something that's now, and it's not in the past, because we didn't have the technology to do that, and it's not in the future, because if we can get past this turning point successfully and learn how to control our technology and use it for positive rather than negative, then we'll be on the road to the stars. So it comes down to us, right here, right now, to decide the fate of the human race.
In the words of Monty Python, and pray that there's intelligent life somewhere out in space, because there's bugger all down here on Earth. Let's hope we can prove it wrong.
Yep.
Look, that's great, Jeff, and it's been good talking to you, and I look forward to talking to you again sometime in the near future and find out about your next great project.
Great. Thank you very much. I really appreciate joining you today.
Great. Thanks again. Okay, that was Jeff Bennett we've been talking to from Denver in the United States, and a lot of interesting topics to ponder there.